Hello, everyone. Welcome. Let's wait 1 or 2 minutes for other participants. Maybe someone can join us. Today, actually, we will talk about AI and model art services. And I would like to introduce myself. I am Hakan Aktas, and I am working on Huawei as a cloud engineer for about 5 months. My main domain actually AI and blockchain. I'm also a master's student at the Galatasaray University on this area, data science. And today I will explain about AI, the basic components, and the modular services benefits. By the way, uh, you can scan the QR code in order to get a registration certificate. Please scan this QR and you will gain a registration certification. And please don't forget to register. Actually, we can start. Today, I will mention about what is AI, and I will try to explain the main idea and its use cases. Then we will cover the AI development lifecycle, includes creating data sets and labeling data, pre-processing data, and if we when we uh, complete our data, training process. I will explain the training process and deploying the AI model. Then I will introduce the Huawei Cloud ModelArts Service. We will cover its functions, and we will understand how can we deploy, develop an AI application. Uh, how can we apply the develop AI development lifecycle on the ModelArts Cloud service by using ModelArts service. Then lastly, I will make a demo actually by using on the Huawei Cloud ModelArts Service. On this demo, I will use a dataset consists of cars. The application scenario will be traffic analysis because when we detect a car on the road, we can use this AI model in this several scenarios. And I'm also planning to make a classification uh, application. The car data set will be object detection. Maybe we can make a classification also. So let's begin with what is AI, and let's try to understand what is AI components. So we can actually easily describe the AI that involves the using computers to do something that usually require human intelligence. Uh, for example, humans can see their eyes with their eyes and process what they see. And we can understand our environments and move around within them. And our brain have the ability to see patterns, and we have the ability to understand spoken languages. Uh, the artificial intelligence can perform the tasks like human. Actually, in order to make a decide uh, any topic, we should use this uh, analysis. We make these analysis. Uh, Artificial intelligence can perform these tasks like human by using actually some mathematical algorithms and statistic and probability. On the other hand, in order to for computers to achieve these tasks, and they require a lot of data, a huge data. Large data sets allow AI algorithm to identify patterns and make these predictions and decisions and recommend actions. Uh, and also I would like to mention about the types of AI applications and their roles in the industries. Actually, all of us, I think we are familiar. Some of them, these AI applications. One of them is machine vision, and we can call that a computer vision also. This technology that helps the computers see and understand the images and videos. It's used in many AI applications. For example, in the factories, and machines has a cameras check the products for detects. The the use cases are very important because we can easily say that the production line is working usually uh, all day, and the quality control is very important. Maybe we can assign a person to detect all the anomalies, but the human can make a mistake, but AI application cannot make a mistake because they are not tired. So the the anomalies cost very high because the AI application is very important on this area. The other very popular area is driving cars, we can say. Machine visions and cameras, computer vision helps the car see the road and traffic signs and other vehicles. The system use cameras to capture images and then process them to recognize objects, shapes, or patterns. On this demo, we can also use a car data set. Maybe we can use the self-driving cars. I don't know. Then other very popular AI application area, speech recognition, we can say easily. We are very familiar to speech recognition because the the technology that allows computers to understand and process human spaces. It uses in many areas. For example, voice assistants like Siri and Google Assistants use speech recognitions to follow voice commands. This technology is also helpful in automatic subtitles, phone systems, and helping people with disabilities communicate. The system listens to what we say and turns the sound into text, then understand the meaning. The other main topic that I want to mention about NLP, natural language processing. It is a field of the AI, helps computers understand, interpret, and respond to human language. It allows machines to read, hear, and communicate with us in a way that feels natural, uh, like ChatGPT. Uh, as I said before, chatbots and translation tools and voice assistants is an example. The AI development lifecycle encompass all stages from designing to training, implementing, and managing an artificial intelligence application. Generally, there are five main stages in the AI development. First of all, one of first of them is data. Initially defining the problem the application is trying to solve and collecting data is necessary because if we collect wrong data, we made a mistake at the beginning because if we give the AI model a wrong data, they will learn, but their its decision will very wrong. So as I said before, the AI application we will use in the real time has covered a lot of all the scenarios because, for example, we will develop an AI application in this demo, car detection application or car object detection application, and we should use data cover all scenarios. For example, the weather should be rainy or maybe today, maybe night. We need to collect all type of data. So the diversity is very important, as I said. Data can be in actually the form of images, as I said, audio, video, text, and others. After this, we collect the data, but we need to prepare data. For example, we collect all data. Okay, I have a lot of a huge data, but we need to examine the data and we decide to. It's very clear, and the data preparation involves cleaning, normalizing, and pre-processing the data. I give an example usually on the image data set, but if we want to develop a machine learning application such as a linear regression model, we will use tabular data. On the tabular data, the type of data can be very different, such as the data types can be integer and float and string. We should normalize it, and we need to determine just one type, or we should clear because maybe our data sets has null data. So the prepare data is very important, and normalizing is very important because we need to rearrange the data between 1 and 0 and 1 because we cannot manage the other scenarios. It's very important to compute capability also. And the other step, building and training model. In this stage, model is created and trained. The model learns using data and algorithms, and is capable of recognizing and making predictions on data. So actually, that's why this is the main the main important topic. And after this, we train the model and we see the results, and we can decide okay, this model is perfect. We will use it on the production line. We should deploy our model on the production server where we application run. And we need to monitor it because the real-time data should be different on the collecting data from the collecting data. And lastly, as I said before, the AI application. The AI application becomes usable and manageable by users. In this stage, the performance of the application and data is continuously monitored and updated. Each AI project is designed differently for different data sets and problems and goals. So the sequence and intensity of the AI development lifecycle stages may vary from a project to project. However, these 5 stages are generally present in all AI projects, whether you use images or text or audio. We will handle these issues. But I would like to say that the all of the components should be measurable and accessible from the developer, because we have a team and we are developing an AI application. All of these are different stage, and maybe if we if we handle this process just one platform, the process, end-to-end process, will be very fast. So I would like to mention about the ModelArts Huawei Cloud Service on this point. ModelArts is a one-stop AI development platform geared towards developers and data scientists of all skill levels. It enables you to rapidly build, train, and deploy models anywhere. As I said before, where is the or production server from maybe its cloud or its edge devices. ModelArts can work in with the all of the scenarios and manage full lifecycle AI workflows. ModelArts accelerates AI development and fosters AI innovation with the key capabilities, including data processing and auto labeling, distributed training, automated model building, and one-click workflow executions. This is also very extra benefit because, for example, auto labeling tool very helpful for a labeling data, because we need when we train a good model, we need a huge data set. For example, 1,000 or 10,000, for example. It depends on our project. But the labeling of these images are very challenging, and it takes a long time. So ModelArts can help us about this. ModelArts has the data governance, rapid and efficient model training, cloud edge device integration, as I said, automatic model building capabilities. It manages data preparation tasks such as data filtering and data labeling, and keeps track of different version of dataset, because maybe we can try an AI model, but we can say that it is working very well. Okay, but the time when the time passed, the data will change, and we need to add an extra data in order to upgrade, in order to retrain our model, because the data shifts is a big challenge of the machine learning and other AI area. So we are usually monitor of the performance of AI model, and we are usually upgrade it. And but when we do this, there is a lot of data version. When we store it on local machine, it will be very complicated. So modulars can help us to version different data set. Also, ModelArts provides high performance distributed training and makes coding easier with its proprietary mixing deep learning framework. Uh, Distributed training is very essential to high performance, because the source is on the cloud, and we can use the all GPUs parallelly, and it's very different from the developing on the local machines or local on-prem data centers. Modulars also, I can say that, allows you to deploy models in various environments, including devices, local devices and the edge devices such as edge devices, and on the cloud. And it supports both real-time and batch inference. We are usually use these edge devices in the real time because the devices should just focus on the AI application. So the edge devices usually cannot communicate other cloud, can communicate, but it is very difficult, such as these AI services on the cloud. But modelars can communicate and work with very well these edge devices. With ModelArts, you can build models without coding, and it supports tasks like image classification, object detection, and analytics. Evet. I would like to mention about its advantages. One of them is one-stop, and ModelArts is an all-in-one AI development platform that offers end-to-end solutions, as I said before. It streamlines the entire AI development process in just one place. It's easy to use. It offers automatic hyperparameter optimization and code-free development for simplified operations. With just one click, you can deploy your model to the cloud, edge, and devices. The other advantages is high performance. Optimized GPU utilization leads to faster real-time inference, and models running on Ascent AI chips and offer even more efficient performance. Lastly, we can say that it's very flexible. ModelArts because supports popular open source frameworks such as TensorFlow, PyTorch, XGBoost, and Huawei's framework Mindscore. Then we will make a demo by using ModelArts on the Huawei Cloud. We will create an OBS bucket, and we will upload our data set into it, and we will get the data by using Huawei ModelArts Service, and we will discover how can we develop and deploy our model. So my theoretical presentation finished. You can scan the link in order to give a suggestion about it. Let's wait for a while. Then I will start the demonstration. I will share my screen and I will show the step by step how can we deploy AI model. Okay, I am sharing my screen. Okay. By the way, is there any question about theoretical parts? I can answer this question before starting the demonstration. If you have any question or comments, you can write the comment section. I will maybe answer it up at the end of the presentation. Okay, actually we can continue. We can start with demonstration. I hope it is very clear. Firstly, we will create an OBS bucket. Then we will download a dataset. We will download two datasets actually, and one of them will be related to classification. Another will be related to object detection. One of them has no has because of the classification has not label, and other will have an XML file. So let's try. Let's start with creating OBS storage object storage service. Uh, I'm clicking the buy OBS package on the OBS service panel. The region should be similar with CodeArts. I'm using the Singapore region. Actually, I think I have a. I have also OBS bucket. Then I will not create a new one. We will upload a file by using OBS browser, but we need to download a dataset before. Firstly, I will download the traffic vehicle detection on the kaggle.com. I'm already download the dataset, so I will not download. And let's upload the files. This here. Okay. Let's click upload. Folder. And the dataset file. And let's click OK. And yes. Yes. I can delete it. It will take time, actually. We can track the progress on the task management. While it's downloading, uploading, I will mention about the data. As I said before, our data set consists of cars and its labeled files. For example, like this. There is a lot of cars, and we would like to detect the object as a car. Maybe the scenario will be counting the car. We can we would like to calculate how car passed on this way, or we can optimize our traffic jam maybe. And let's look at the label file. Maybe you are familiar this structure. The structure is named XML, and we can say we can see the all details on this here. We can see the size of the images, the file path of the image, and as I said before, this is an object detection label, so it need to consist of bounding box coordinates and these classes. Oops. And you can see there is a lot of label. By the way, it will still continue. Actually, the uploading process is very long. In order to don't wait so much, I will make a different parallelly a project, a classification project. On the Huawei Cloud console, I will open the ModelArts, and I have been uploaded the dataset before. Here, the dataset is related food. This will be a classification. As you can see, there is a 7 class, such as donuts, ice cream, and you can see the number of labels is here. Actually, I forgot to introduce AI Model Arts page, and you can see the dashboard here and how much notebooks do you have, and workflows, training jobs, and real-time services. And on the development production section, we have three types of choices. We will use the XML. Uh, Also, this is the or application section, and also we have a data preparation page. We are using this page to label our data. For example, you can see the all of different data, and you can see the labeling process. And as I said before, labeling process is very complicated, and maybe sometimes we have a lot of huge data set, and we can assign it the labeling process all over the team, and we need to track the labeling process. On this page, we can create a labeling job, and uh, let's explore the data set. For example, you can see the labeled number and unlabeled number. There is no unlabeled data, so it's very good for us. And this is because of the classification model, there is not a bounding box. And it's like this. We can create the labeling teams here, and the model training page. We can create training jobs and model deployments. We can deploy our model that we created and trained before on the real-time services or batch services. And we have also asset management. As I said before, we are store our data here and customize data sets, and we have also create a customized algorithms, for example TensorFlow or PyTorch or XGBoost. And it's our AI application and image management. We can also permission management section. Let's begin to train a classification model. As I said before, there is 5 different application choices. We will use the create. We will use the image classification, and let's click the create. We can say the classification, and I will select the data set here because upload the result. We need to create a new folder. Okay. And we will select the GPU because the performance. Let's create a project. And when we click the create project, it will automatically start the pipeline. Firstly, it will check the data labeling. We get an error. The label task already exists. Okay, let me check. Because I forgot to delete. I think yes. Let me delete. all of this, and we can start again. Okay, I will select the file that I created before. Okay, and I'm selecting the flavor again, and I'm clicking to create project. Let's wait. We can click the next. We say that please check, but I know that everything is okay. I hope. Yes. Actually, it will check the labeling. Uh, Maybe if there is an unlabeled data, they if modelers say that there is an unlabeled data, you can check it because it will damage for your AI algorithms. And when we start a new training, it will create a data version automatically, and it will validate the data. After all of this, it will be start the image classification model training. Then we will deploy it on the cloud. And on the other hand, yes, the process also finished. The process will take a long time, actually. So it was the classification application. We will wait until the end. So while this processing continue, we can move on the object detection section site. We will upload all of the images, all of the data here. Let's take check. The image structure should be like this, and one of the image and labeled image has similar name of the image. I showed the content of this XML file like this, and on the ModelArts service, we can create a new data set. Yeah, let's open a new tab because I don't want to lose it. Okay, as I showed before, we can create a new data set here, and I'm clicking create demo cars. Okay, and we will check it here. Card 2. I will select data as I uploaded before, card 2, and I'm clicking the OK. And also I will create an output folder in order to upload out. Um, I'm clicking submit. Yes, we are created a new data set. It takes 1 or 2 minutes. Let's wait. You can see the progress is here. We are also labeling the data because I'm deleted the two labeled data in order to show how can we use the data preparations. Let's wait. It's loading now. Okay. Let's check it. On the data preparation section, we can see our data set. Yes. No. Demo classification. Let's wait. I think it didn't. Data set. That's it. Demo cars. Label data. Actually, we can use this data set here as I upload same data in here because the number of data is small and the training process will be short, and we can use this, but the context it is similar. Or label data. Let's check the classification. Yes, image classification model is running now also. Let's look at the logs. What is the progress? When we click the instance details, we can access the detail information about training. Oh, sorry. I didn't click image classification. It is running and instance details. Okay, everything seems perfect. Let's check the logs. Yes, training started, and let's wait. The loss level is good. It should be low. The loss level, we can see loss level, loss functions value. We can say that the differentiations between real value and predicted value. And if the loss value is low, we can say that model can predict very correct, very good. Okay. On the other hand, what about our car data set? I think it will not upload because of the network. I don't know. Images are here, but the labels are not here. I will try again, but I will check. I will upload. I will delete it. I think because of the internet. I will delete also. Because available for creation is, we need to decrease them. And I'm opening the OBS browser. I will upload our data again. Card 3. Okay. This file has smaller data than card 2. Our training process will be shorter than before. Let's check, by the way, classification. It says that successfully opened the CUDA library. CUDA library actually means that it helps us to use the GPU cores. For example, uh, in order to calculate the neural network is difficult because we are calculate the image data set, and images can be represented as a matrix, and matrix calculations has a need to big compute capability, and so we need to calculate it by using GPUs, because GPUs has more than GPU has a lot of core, more than CPU. So the training process is faster. Our model training has completed. Before the deploy, I want to start this training. It will finish now because I have 15 image. Yes. Okay, perfect. So let's move on the model arts and create a data set as we do before. Data sets, parse, demo. On OBS, images, path, and we can select the image path, OBS bucket. Oh, card 3, yes, card 3. Labeled, yes. Object detection, and we will select the Pascal Vogue type of label because we have XML file, and if we want to, if if we if our data labeled format is TXT, and we can choose the YOLO format. Okay. Output customer, is it empty? No. Okay, I will. I created a new file, and I will click submit. By the way, I can answer any question while waiting the uploading. Oops, yes, it uploaded. Perfect. There is one images that I'm unlabeled, so let's label it. I will create a labeling job task. Okay, let's create. Oops, label already exists. Okay. Okay. Unlabeled image here. Yes, we can see that the labeled images here. So It's very actually helpful for me, for AI developer, I think, because when we finish the labeling process of our data sets, we need to overview. But yes, there is a lot of labeling tools such as label image, but we cannot see all of these pictures like this. And I will show also quick review. Maybe I think it's very useful because you can see all of the objects just one page. And if we don't like any labeling, for example, if you don't like any labeling, you can change it here very simply, and the changes will be upgrade on all the or data set. For example, let's try. For example, I don't like to labeling because it need to be cover all the cars. It's good, but we can readjust it like this, for example. Okay, when we exit it, and you can see that it there is a tag. It said that it's modified. For example, it covers very huge. We can make it smaller. For example, I need to be do like this. Okay, and you can see that it's modified, and apply all modifications, and okay, and let's label the images together. The labeling uh, page very useful. We just click the rectangle because our project about object detection, and okay, like this cars. Yes, it will take a long time. It is boring, I know, but let's finish together. Okay, car. Yes, car. Uh, we shouldn't pass any car because if we don't label, for example, other cars, or AI model work uh, when the AI model work on this image, uh, it can detect the car, and if we ask the they said that this is car. I know I learned this is car before my experience, but it will look at the label file, and it will not see the label. It will be very harmful for our AI model. The background is very important. Okay, I will finish, and I will save it. Okay, back to the labeling page. Okay, you can see that unlabeled image 0 and labeled is like this. And let's move on the development workspace as I did before. We will use object detection. We will create a project XML cars demo. I will create a game in an empty file. like this, and click OK. And I will select the flavor, and I will create a project. Okay, we can say next. I will check it. And this process will take a long time. Actually, let's take a break for about 5 minutes, and we will come again. Allah. Hello everyone again, and our training session started, and let's check with the logs. The classification models training was finished, and we will deploy it, and we will test the performance by using the public image that we didn't give the training process before. So we can see the events log is good, and when we look at the logs file, we can see the progress. We can see the progress here. All of them actually is one epoch. Epoch means we have determined some hyperparameters before training the deep learning model, such as batch size and epoch size and learning rate and etc. We have a data. We need to feed the neural network with the data set, but we need to decide something before starting training. The hyperparameters are optimized by the Huawei Cloud ModelArts Service, but I can explain it. For example, our data set number is, for example, 10. If I determine the batch size as a 1, I will fit the neural network on just one image on the one epoch. For example, we can easily understand this period. The one just one image will be join the one epoch on the neural network. It's really important or training process because it will impact our compute capability. If we determine the value very small, our compute capability will not very fast, but the training time will be long because the training will be slow. We are giving the data to neural network one by one. And epoch size is very important because maybe you are familiar that for example, sometimes when we I forgot the terminology. Sorry. How can I explain without the terminology? For example, the training performance is very critical. It depends on our data set diversity. For example, if we have a large data set, our data diversity is high, and or data fitting curve will be adapted, or data will not be adapt or data very well. So we can say that it's not under slow learning because when we feed the AI model different data, it can say that yes, it will not work so much because it's supposed that I know it. So the hyperparameters are very important. Maybe I can mention about the. I'm sorry about it. I forgot the terminology. The terminology is here. I explained epoch size and I can also mention about the object loss, class loss, and total loss. Actually, the main important term is total loss, because as I mentioned before, it means that or neural networks predicted some value. For example, it says that this is a car for uh, for 18 accuracy, 18 percent. But I know that it is not car because I have labeled data. When I calculate the difference between, the difference will be very high, because we can say that it's the total loss, and we can easily say that if the total loss function value is small, the performance of AI model is perfect. Maybe I can mention about optimizing algorithm, because back propagation, the loss function will be calculated by using optimizing algorithms such as gradient descent algorithm. It depends on mathematical approaches, and we are on the half of the epoch. I think we can deploy the classification model. Yes, service deploy. I can select specification here and next. Yes. Proceed to next. Yes. Creating. Yes, status is creating. After it is done, we can test our model that we trained. Demo classification is running. Okay. After it's done, we will deploy our model here on batch or real-time service. This is my previous. I can delete it. Is it right? Let me check. Yes. The deploying process will be completed soon. I can delete it. Because it causes a problem when we deploy our model sometimes. Total loss decreasing, right? Yes, I forgot to mention about MAP value, and you can see the MAP value here. MAP value is related to accuracy, actually, the performance of the model. We can say that if it is higher, it's near to 1, we can say that the performance is okay. Yes, I remember the terminology, but I can say that we can say that this is not the best scenario. The MAP value is near 1, because if we have a higher MAP value, maybe our neural network adapted so much our data, and so overfitting maybe become. Overfitting is very dangerous, uh, because maybe we can happy to see higher MAP value, but when we deploy the model on the real time, uh, because of our neural network is adapted so much our data, when we need any data, it will not determine. It's very dangerous in real time on the deploying model. Let's oops no deploying process, yes, running. Let's predict. Let's test our classification model, and yes, our deployment successfully completed here. I can test our data by giving local image. I can upload AI demo dataset images. Maybe you remember, maybe you don't remember. The classification model was relating the food, and I will give the ice cream date images, and I hope the AI model will detect the ice cream very well. Okay, and I'm clicking the predict. Yes, it's confused, but let's we can find also barbecue chilled noodles. I think it's not. It depends on actually the training epoch size, maybe. I can find ice cream on the Google image save, and here images 2, images 2. Let's upload a new file. Open. Let's predict. Yes, ice cream. You know that. Actually, the process will be very similar. Actually, the time is going so hard. Is going usually, and I actually when we finish the training process, we will make a same step. We will just deploy the model. I think we can finish the presentation. We don't need to wait so much. Is there any question? Okay. I'm looking. I think this one. Yes. I think this ModelArts tool is being used for labeling and training the dataset in the machine learning algorithms, right? Yes, Kerem, you are right, actually, in your opinion. Huawei Cloud ModelArts Service has end-to-end functions, AI development. What does it mean? the first step, as I said before, creating data set from different devices, different sources. And if we want, if we storage or and version the data, the first step is completed actually. And the other step is labeling the data. The labeling data is very crucial, important for a huge data set and big teams, because we are spending so much time to label data, and we can use ModelArts to assign the team for labeling data. And you can you are right, and we can use the ModelArts for labeling. And as we do two version classification and classification model training and object detection model training, we can use ModelArts, as you see, with different algorithms actually. For example, you can use the machine learning algorithms such as random forest algorithms and XGBoost, or whatever you want, because you can manage your algorithms here. I hope this answer is acceptable for you. Is there any question? Thank you so much for listening. I think we can finish the presentation.